We often imagine artificial intelligence as an instant oracle, a monolith where raw information goes in and perfect answers emerge immediately. The reality is that real-world information is naturally disorganized, plagued by typos, duplicate entries, and missing values. Feeding this unrefined chaos directly into an algorithm causes the system to fail spectacularly. Reliable AI emerges from a meticulous, multi-step engineering pipeline. Predicting the fair market price for a single home relies on this systematic construction. Intelligence must be engineered. Building a model is similar to cooking. You cannot prepare a gourmet meal using ingredients that are still covered in dirt. In our real estate example, the first step is purely janitorial. We have to comb through the historical housing data to delete duplicates, fix formatting errors, and fill in missing values. Watch this messy grid reorganize into a clean, uniform table, creating a structured foundation. Even with clean data, the algorithm filters out noise to focus on what impacts price. These are features, curated information used for predictions, like square footage, bedrooms, and building age. The color of a front door rarely dictates a home's value, so we discard it. Square footage is a primary driver of price, so we keep it. Selecting these features is the most critical human decision in the pipeline. This determines whether the machine has the right materials to learn the market. We provide these features to the training set, the specific batch of historical home sales the algorithm will use to study the relationship between a house's characteristics and its final price. The machine begins by making a blind guess. It has no initial concept of what a house should cost. The system compares its guess to the actual house price, measuring the error gap between them. Based on that gap, the algorithm makes a micro-adjustment, bringing its next guess closer to reality. This guess, measure, adjust, whoop repeats thousands of times in rapid succession. Training is a relentless, automated process of error reduction until the algorithm's output successfully mimics the real-world data. Eventually, the loop finishes. The model can now predict the prices of every house in the training set with 100% accuracy. In the world of machine learning, a perfect score is a warning sign. This is overfitting. The model wildly contorts its logic to hit every single data point exactly, ignoring the obvious, simple trend that actually defines the market. The system has simply memorized specific houses. It has failed to learn the general rules of real estate. This model is like a student who memorizes an old exam's answer key. They can repeat the past perfectly, but they cannot solve a new problem. To catch this error, the pipeline requires one final, unforgiving step. We introduce the test set, new, unseen houses that the model has never encountered. As these new points appear, we see the overfit logic fail to predict them. Successful models maintain their accuracy on this new data, proving they have generalized the relationship between features and price. Machine learning succeeds by uncovering the underlying patterns of a dataset, allowing a system to navigate an unknown future.